Why sleeping helps you understand difficult ideas. When I first began studying econometrics and statistics, I discovered something rather discouraging. I would read a chapter carefully, slowly, diligently, pencil in hand, and understand almost nothing. The equations seemed cryptic, the notation unfamiliar, and the logic stubbornly resistant to my efforts. After an hour or two, I would close the book, slightly irritated with myself, and go to bed. The strange thing was that the next day, when I opened the same chapter again, something had changed. The equations looked less mysterious. The structure of the argument was clearer. Ideas that had seemed impenetrable the night before suddenly began to make sense. This happened again and again. Eventually, I reached a slightly subversive conclusion. Sleep seemed to be teaching me more than the reading itself. At the time, I assumed this was simply a personal peculiarity. In fact, modern cognitive science suggests that this experience reflects a fundamental feature of how human learning works. Subjects such as econometrics, statistics, or mathematics do not simply require memorization. They require the brain to build conceptual structures. When reading a difficult chapter in econometrics, A is simultaneously trying to interpret several different layers of information: mathematical notation, statistical reasoning, economic interpretation, assumptions about causality and model structure. Understanding emerges only when these elements become integrated into a coherent mental framework. Psychologists such as Sweller in 1998 often describe this challenge in terms of cognitive load. According to cognitive load theory, the human brain's working memory, the system responsible for temporarily holding and manipulating information, has very limited capacity. When the complexity of the material exceeds this capacity, comprehension temporarily breaks down. This is why the first encounter with an econometric model often feels confusing or overwhelming. It is not necessarily a sign of intellectual failure. It simply reflects the limits of working memory when confronting unfamiliar conceptual structures. The fascinating part occurs after the student stops studying. For a long time, sleep was thought to be a passive state in which the brain simply rested. Research in cognitive neuroscience now shows that sleep plays an active role in learning and memory consolidation. During sleep, particularly during slow-wave sleep, the brain begins to replay patterns of neural activity associated with recently acquired information. These patterns are gradually reorganized and integrated with existing knowledge structures. Diekelman and Bourne, 2010. In simplified form, the process looks something like this. New information encountered during the day, temporarily encoded in the brain, neural activity patterns replayed during sleep, connections strengthened and reorganized, more stable conceptual structures formed. This process is known as memory consolidation. In effect, the brain is quietly sorting through the information encountered earlier, extracting patterns and building conceptual frameworks that were not yet fully formed during waking study. Econometrics is an excellent example of a discipline that benefits from this process because it requires the integration of several forms of reasoning: mathematical abstraction, statistical inference, economic theory, causal interpretation. The same principle applies to any type of learning. Understanding an econometric model involves constructing a network of relationships between these elements. The brain rarely builds this network instantly. Instead, it assembles it gradually through repeated exposure and consolidation. This is why the second or third reading of a difficult chapter often feels dramatically easier than the first. Your brain has already begun organizing the structure overnight. Students often interpret confusion as a sign that they are failing to learn. From a cognitive perspective, the opposite may often be true. Initial confusion frequently indicates that the brain is encountering new conceptual structures that it has not yet integrated with existing knowledge. Exposure to the material creates the conditions for consolidation to occur later. Educational psychologists sometimes refer to this as desirable difficulty. Bjork and Bjork, 2011. Learning conditions that feel effortful can often lead to deeper and more durable understanding. In other words, the frustrating first encounter with a difficult chapter may actually be an essential step in the learning process. Many students discover that complex subjects are best approached through a rhythm that alternates effort with rest. 1. Read the material carefully. 2. Accept that some parts will not make sense immediately. 3. Stop after a reasonable period of study. 4. Sleep. 5. Return to the material the following day. Clarity often emerges gradually rather than instantly. It can feel almost as though the brain has been quietly working on the problem in the background. When students encounter difficulty, the instinct is often to study longer and longer in a single session. However, without opportunities for consolidation, the brain cannot reorganize the information it has encountered. The result can be cognitive fatigue and diminishing returns. Effective learning often involves cycles of focused effort followed by periods of rest, allowing consolidation processes to occur. So was my early conclusion correct? Does sleep teach more than reading? Not quite. Reading provides the raw material. It exposes the brain to new ideas, symbols, and relationships. Sleep performs a different but equally important function. It reorganizes those ideas into structures that the mind can understand. Learning, therefore, has 2 stages. The day shift, when we encounter new information. The night shift, when the brain quietly organizes it. If you ever read a demanding chapter and feel completely lost, take some reassurance from this idea. Your brain may simply be waiting for the night shift to begin.